Okay, let's look at expressions and where they are defined and undefined. We have two common expressions here that we have to worry about where they are defined and undefined. One is a rational expression. That means it's a fraction with x's on the bottom. And one is a square root. So with rational expressions, you ignore the top. That's why I crossed it off. So ignore the top. Put the bottom not equal to 0. The bottom of a rational expression cannot be equal to 0. With the square root, you cannot have the square root of a negative number. That means the inside the square root must be either 0 or positive. So with the rational expression, the bottom is not equal to 0. With the square root, the inside of the square root must be greater than or equal to 0. So then we solve and we get x not equal to -5 and x greater than or equal to 6. So those are two very important cases, the rational expression case and the square root case. Okay, so now we're looking at the product of two square roots. Write an inequality that represents all values of x for which the product is defined. So not where is it undefined, where is it defined? So we know that what's inside the square root on the left, the 3x must be greater than or equal to 0. And on the right, the 2x plus 1 must also be greater than or equal to 0. So we solve our inequalities. So x must be greater than or equal to 0 and x must be greater than or equal to -1/2. So let's see what that looks like on a little linear graph. Here's my endpoints at -1/2 and 0. Here's x is greater than or equal to 0. And here is x greater than or equal to 1/2. So I need all values that are greater than or equal to 0 and greater than or equal to -1/2. So that leaves us with x greater than or equal to 0. Those are the values that are true for both statements.